Hey guys, I'm going to go through the past paper questions that are set for you and then you're going to do your test today as well. So question 1, the drug metoprolol prevents stimulation of postsynaptic receptors in the sympathetic nervous system. You should be thinking straight away, right, sympathetic nervous system, that prepares you for activity, prepares the body for activity, and it involves the medulla oblongata, which is to do with non-skeletal muscle, and which is also referred to as involuntary muscle. So we're talking like regulation of the heartbeat, breathing, so your lungs, blood vessels, dilation, so on. Okay, because if you think about preparing the body for activity, it's all about getting adrenaline pumping, getting your heart going faster, getting your lungs working faster, getting your blood vessels constricted so that we increase blood pressure, get stuff moving around, constrict blood vessels that are going to the digestive system, and dilate it where it's going to muscles so that you can get more blood to your muscles. So back to the question, which of the following conditions could this drug be used to treat? Muscle fatigue, tachycardia, which hopefully you remember from last year means a very high heart rate, so above 100 beats per minute, or high blood pressure. Well, it's not going to be muscle fatigue because we're talking about the sympathetic nervous system, and we're talking about preventing stimulation of basically the sympathetic nervous system. So we're trying to prevent things that are to do with the medulla oblongata and non-skeletal muscle, so heart rate, blood pressure, and so on. Tachycardia, yeah, heart rate, that is to do with this area. And high blood pressure, yeah, that's definitely to do with this area. So not muscle fatigue, so hopefully we've got an option for 2 and 3. So it's not that one, not that one, not that one. So the answer is C. Okay, question 2 has an image of a brain. And before I start looking at the question, I would probably have a go at labelling the areas. So Z is pointing to the cerebrum, or it could be pointing to the outer layer of the cerebrum, which is the cerebral cortex, which is that wrinkly outer layer of the cerebrum, which is for intelligence, higher thinking, consciousness, conscious decisions, emotion, memory, and so on. Okay, so that's this top part here, the wrinkly part. Next we've got here, now this arrow is pointing to the leafy shape thing, which is the cerebellum, which is involved with balance, coordination, fine motor control, things like that. X is pointing to the medulla or medulla oblongata, and that's involved, like we said in our last question, that is involved with heart rate, breathing rate, blood pressure, all of those unconscious things. And then Y is pointing to the hypothalamus or the hypothalamus pituitary complex, because there's the pituitary gland there and the hypothalamus is sort of here. So hypothalamus pituitary, which is involved in homeostasis, so regulation of things like water levels. It's involved in, so let's put homeostasis. So like temperature, water levels, and so on. Okay, so now I'm going to look at the question. Which of the labelled regions would be directly involved in learning to play a musical instrument? Not the hypothalamus, so it's not going to be Y, because we don't need to be controlling our temperature or water to be able to play an instrument. Medulla, heart rate and blood pressure, not really directly relevant, so that leaves C, so let's just double check. W, the cerebellum, so balancing, coordination, fine motor control, so being able to coordinate your fingers, hands and so on. So yes, that would definitely be needed for a learning to play a musical instrument. So W definitely, and then the higher thinking, intelligence area you'd need. So Z as well. So definitely those two, which luckily matches up with the one that we worked it out to be. Okay, question 3. MRI scans have been used to investigate the structure and function of the human brain. Scans are essential when health professionals suspect that a stroke has occurred. So a stroke is a bleed on the brain or a blood clot on the brain. Blood clot on the brain. And again, it's pointing to several different areas. So I would just quickly think about, well, what are these different areas? And I'd go, right, we've got our leafy shape here. So that's our cerebellum, which is our fine motor control, balance, and so on. This one here is pointing to our medulla. Here we've got the brain stem. And then up here we've got the cerebrum, cerebral cortex, which is the outer layer, and we can see that wrinkly area. Okay, identify the following structures. Okay, nice and easy. So B, we know, is the cerebellum, that leafy one, which is involved in fine motor control, balance, and so on. Cerebellum. And then C is the medulla or medulla oblongata, either is fine. Okay, next question. Hot flushes are one of the symptoms associated with menopause. These symptoms are thought to be linked to falling estrogen levels. Okay, you should know that that estrogen is secreted by the pituitary gland. And you should know that thermoregulation, thermoreg, is in our little homeostatic area. So our, why do I always forget my hypothalamus, pituitary complex. Uh-oh, pen's running out. So low levels of estrogen are thought to disrupt the thermoregulatory centre in the brain. Good, that kind of makes sense. It's talking, that's what we've already deduced, is that we're talking about this area. Name the part of the nervous system which includes the brain and state the exact location of the thermoregulatory centre. Okay, so thinking to that lesson that I set you where you had your flow chart, where it splits up the nervous system into the central nervous system, peripheral nervous system, motor, sensory, all of those different parts. So the brain is part of the central nervous system. I'm gonna have to get another pen in a minute. central nervous system. Come on, just let me finish this one question. Exact location. So again, already mentioned that you should know that the thermoregulatory centre is in our little, what did I say before? Our homeostatic part of the brain, which we said in the first question is our hypothalamus, our hypothalamus pituitary complex. So, hypothalamus. There you go, you can just about see that. Right, I'm going to get a new pen for the next bit.